Hi guys, I hope you all are doing well. Welcome back to the training. Today we are going to focus on a couple of more concepts where we'll be discussing about some wireless related concepts and then gradually we'll be speaking about the tunneling concepts of GRE and IPsec. So let's get started. Let's see how things go for wireless networks. There is a lot of theory related to the wireless concepts. We'll try to discuss all of it here in the session. We'll also be observing some authentication related configs that we can perform on a wireless controller onto our lab setup. So let's see how that goes. I'll quickly share my screen. So when we speak about wireless networks, there are a lot of benefits that we get to see when we are switching from a wired instance to a wireless instance. There are a lot of benefits that we get to see, but along with that, there are some limitations as well that we have to address when we are working in a wireless environment. So what do you guys think are some of the benefits that we get to see in a wireless scenario compared to a wired scenario? Let's speak about some benefits first. So what do you think are the benefits of a wireless environment? The
Sort of.
installation and the cabling cost can be removed because we have a easy to install setup, so that makes it cost effective. So mobility is something that is provided by wireless networks, where you can move around in your room or in your office while being connected to the network. Whereas in the wired connectivity, we don't get to see that, right? That's again very correct. Then what would be the next benefit of that? So when we speak about wireless networks are, again, like I mentioned, this is something that you utilize to connect with the devices over radio frequencies, right? For example, the network types that we have been observing were having a router, then connected to that particular router, there was a switch, and that switch allowed me to connect multiple end devices to it. But that connection had to be wired, right? When we switch to the wireless LANs, the scenario is a little different. What we do is we take up a router, we take up a switch, and then we connect some access points to it. These access points basically transmit the radio frequencies on which my end users or clients can connect, right? Now, there are different types of wireless networks. The very first type of wireless network that we all must have used at some point of time is called the ad hoc wireless LAN. When we speak about ad hoc wireless LAN, it basically enables a communication between a very limited number of devices. Just like we connect one PC to the other PC using a wired connection or a cable, just like that, in a very simple and temporary basis, on a temporary basis, the ad hoc wireless network gives you the ability of connecting your devices together. So there is no infrastructure needed in this type of connectivity. You just need your devices. No requirement of any router, any access point, nothing is required. You simply need the devices that you want to communicate with each other. For example, I want my first mobile or the smartphone to speak with my second smartphone to share some files. Now, at some point of time, you must have used applications like ShareIt, where a connectivity is established over the Wi-Fi. On one device you enable the tethering or hotspot, and on the other one you try to connect on the same network, and then you share those files, right? Otherwise, popularly speaking about one of the Apple's feature, which is AirDrop, that's a similar scenario, right? It allows you to share files between your iPhones using Bluetooth or Wi-Fi without a requirement of a cable or a access point. So this type of connection that you build without the requirement of any network infrastructure is called ad hoc wireless LANs. Okay. A very popular example, I'll write down here, Apple AirDrop. What technologies are used? Bluetooth and Wi-Fi. Now, what are the limitations? Very obviously, the scalability is not something that we can observe in this type of environment. We cannot use it for even, let's say, 10 to 15 devices. It is not going to work without a experiment or without a router. So the primary purpose of this type of connectivity is a very temporary connection between a very small number of devices. That's your first type of network, which is ad hoc wireless LAN. Next is very popular one, which we mostly observe when we speak about wireless LANs, infrastructure wireless LAN, the one that we were speaking about earlier, where we connect a access point. Infrastructure wireless LAN is the most common type of network setup that you will find for wireless connectivities. This includes multiple devices. We can't just work with client devices. We can't work out with smartphones or laptops only. We require some network components as well. What do we require? We require a wireless access point. Okay. And along with these wireless access points, sometimes we also require a wireless LAN controller, which is used to manage these access points. So when we speak about connecting devices, we connect them through these access points. Access points basically are devices which are physically connected to the network infrastructure. Like I showed you, there is going to be a router, there is going to be a switch, and to that switch, there will be multiple access points connected. All these access points will transmit the radio frequencies over which my clients can connect. Now, scalability is not a problem here, unlike the ad hoc environment, right? At any time, I want to extend my coverage. I can just strategically plan where I should be placing my next access point, because again, wireless device installation requires you to understand the concepts of physics as well. You need to understand how much coverage a particular access point is going to uh, provide. And on the basis of that, you need to plan out things very strategically, that where exactly the next access point should be placed so that there shouldn't be a disconnectivity when someone moves from a point A to point B. So all those strategies, all those calculations are definitely required, but that's not something of our concern. We are just here to understand how they can benefit us, right? So this type of setup can anytime allow you to add up more, you can say more of the devices to give the users a seamless experience where they don't have to get disconnected or where they don't have to lose their connection if, for example, they are moving from a point A to point B. So that continuous connectivity is something that can be ensured if the strategies and the calculations are done very correctly and are done nicely, right? Then when we utilize a setup like this, we use a WLC as well with a certain type of access point. We'll be speaking about what exact type of access points require WLC, but we use it. And this gives you a lot of options to monitor and control the access points. So you get the idea of what is the bandwidth utilization, what number of clients are there, what number of, you can say, I mean, what number of users are there? How many are authenticated users? How many are just trying to connect? So a lot of information is also gathered when we deploy a scenario like this. So that is again a better scenario for a good management, for a centralized management we can see. And it also gives you the real-time reports about all these stuff, about bandwidth utilization, the number of users, number of active users, number of disconnected users, all that stuff. Yeah. So these are some benefits. Now, where do we use it? We use it everywhere. So in your enterprises, in your uh, public, you can say spaces like a cafe or a restaurant or a hotel, all these are utilizing this type of setup only for providing a seamless experience to their clients or customers, right? Then another type is something where we utilize mesh access points. Now, mesh access points provides you a very flexible solution for extending your wireless networks. You might have heard about, like, you might be having a lot of you all must be having different ISP connections at your home or maybe at your offices, right? And you must have heard about a device that basically just extends the coverage of your Wi-Fi networks, right? So that's nothing but a sort of mesh access point. What it does, it extends the network coverage without a need of cable. So what sometimes people do, let's say they have this as their room one, where there is a wireless setup, there are radio frequencies going on, right? Then there is this room number two, where they want these radio frequencies to be present, but because of the limited coverage, the router is not able to transmit up to that particular level. So to relay these signals from room number one to room number two, we install a device here, which is a access point only, a mesh access point being specific. And what it does, it extends the coverage by transmitting the same, or we can say relaying the same signals from coming from the room number one to the room number two. So mesh access point can connect wirelessly. You don't require any type of cable connection. They can connect to one particular wireless setup and can transmit these signals from that particular setup to another, you can say, another amount of area. So these access point receive signal from one side and retransmit them to extend the coverage of that particular network, right? Now, very obviously, you can see that advantages of this type of device is flexibility. You can put it anywhere to extend the coverage. So it provides flexibility of extending coverage without the need of cable connection. The only thing that you require for a mesh access point is a power source. That's all. You don't require any other type of connectivity or any other type of uh, ability for increasing the coverage of your wireless network. So one benefit is flexibility, provides scalability to our wireless network. Then ease of installation is there. No need of any cable or any type of connection between your access point and the other access points. You simply need to deploy the access point up to the desired location, and without worrying about Ethernet cable or any kind of connectivity, you can let it extend the coverage of your wireless network. So these are some examples. Now, use cases can be any scenario where you want to extend the coverage. Um, let's say you have a cafe where you want to, let's say, provide the wireless network to the people waiting outside, where let's say there is a sitting area and anything, and you want to provide the signals there as well. So you can deploy a access point between your sitting area, the waiting area, and the cafe, so that the frequencies coming or passing through the cafe area can be transmitted or retransmitted in the waiting area as well, so that people sitting in the waiting area can also stay connected to the networks and internet, right? So that's your mesh access point. Now, when we speak about all these access points, there are two major categories of them, be it your normal access points or the one that we use in enterprises. There are autonomous access points, and then there are lightweight access points. Let's understand what are these two. So we can say access points are of two types: autonomous access points and lightweight access points. So access points can be managed in different ways. There are benefits and use cases where we require both the types of management, and they can have their own benefits and you can say advantages. So let's speak about the autonomous access points first. Autonomous access points are independent. Okay. So when we speak about autonomous access points, they work independently. They are independent. They don't require any kind of support from anyone. They are enough for themselves and can work basically, can get configured directly by themselves, right? So autonomous access points operate independently and are managed individually. This is a kind of con or kind of limitation here, that they are also managed individually. So let's say you have 50 access points, you have to put configuration on all 50 of them one by one individually, because they do not have any kind of knowledge about other access points or any other device that is operating. They can't be managed centrally, you can say, right? So individual management is there, along with being independent. Sorry for the spelling error. Along with being independent, they are also individually managed. There is no sort of any kind of administration or central point through which we can connect to or manage these connected access points. And this makes it very obvious that we will be only using it for small setups, right? So we won't be using it for a very big environment or a big network. It is only ideal for a small network where there are very limited number of access points required. Now, the benefit of this is a simplicity. First of all, you don't have a lot of configurations to do. You have a simple setup. You can manage access points directly by connecting on them. And this is also cost effective because you don't require an additional controller to manage these access points, right? But then there are cons as well. Scalability is a problem. We can't make it scalable. You can't use it up to a certain number because of the problem of individual management. So you can't just use a central device to manage all of them. You'll have to write down the configuration on all of them individually. Then since they cannot communicate to each other, they also don't know what's happening or what's the uh, problems that maybe my other access points are facing. So such kind of exchange of knowledge or exchange of information is not there. So lack of coordination or lack of knowledge can be a problem when we are using autonomous access points. Now on the other side, we have got lightweight access points. Lightweight access points, like I said, they are managed using a WLC, wireless LAN controller. So now you'll have a different setup. In the case of autonomous access point, the setup would be a router, a switch, and access points directly. But now there would be a router, there would be a switch, there would be a WLC, and then that WLC would be used for managing these access points. So it gives me the ability of managing the whole setup, the whole number of access points through my WLC. And what does it benefits me with? It provides me central management. So there it was individual management. Now we have got central management because the WLC is the boss, right? WLC allows you to manage all the access points through a central point. Scalability is not a problem now. So scalability is something that is offered by this type of this type of lightweight access points. So scalability is not a problem. Then because you have a WLC, it becomes a little more advanced, or it allows you to use more enhanced features, which makes it a better setup. Then the only problem is complexity, because now you will have a lot of configuration, a lot of devices, a little bit of complexity would be definitely there. Now, when we speak about this setup, it utilizes a protocol CAPWAP for exchanging information between WLC and the access points. Okay, what is this protocol? Protocol used for exchanging information between access point and WLC is, earlier it used to be something called as LWAP, which is lightweight access point protocol. It's an older protocol. We don't get to see it nowadays. Now we see CAPWAP tunnels. CAPWAP stands for control and provisioning of wireless access points. So once these access points are discovered by the, you can say by the WLC, they try creating a connection, a CAPWAP tunnel is created, then they exchange information about the configurations that the access point is supposed to operate on. Now the choice between the autonomous access point and lightweight access point depends upon the size of your organization, how much cost you are willing to consider for the setup. That's again an important point to consider. Then what type of management you want? Sometimes you may not want centralized access to all the access points and you have a small setup. So you can definitely go for autonomous access points. Otherwise, we have got the option of lightweight access points. This is about how access points and some of the devices operate in the wireless environments. Now, there are some basic terms, basic you can say terminology that gets into picture like SSID. SSID, I'm pretty sure you all must be already aware of. SSID is service set identifier, which is nothing but the name of your network. Then other than this, in through your wireless concepts, it is pretty important to understand the aspects of security, which we are going to speak about. But before we get there, any questions so far?
All good from me.
Awesome. So just being clear here that we don't have it in the CCI lab attempt. We have it only for the NCORE certification exam. And also, like, you don't really need to study it if, let's say, you are already certified and you are eligible for the lab exam. But if, let's say, you are willing to appear for the NCORE exam, then the wireless security is a pretty important part that you should be well aware of. Okay. So up to this particular level, we had a little idea about how wireless networks operate.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.